In 2014, a Hollywood blockbuster predicted what NASA would photograph in 2019, not in a script, not in marketing copy, in peer-reviewed physics. The visual effects team made a discovery that astrophysicists wouldn't confirm for 5 more years. This is the story of how Christopher Nolan accidentally became one of the most cited filmmakers in the history of theoretical physics, and the 3 things they had to lie about to make the movie watchable. When Christopher Nolan started developing Interstellar in 2008, he wanted something Hollywood almost never asks for: scientific accuracy. Not approximate accuracy, real, mathematical, peer-reviewable accuracy. So he hired Kip Thorne, a Caltech astrophysicist, who would later win the Nobel Prize in Physics. Thorne didn't sign on as a consultant, he signed on as an executive producer. His job was simple: write the actual equations that describe what a black hole looks like and hand them to the visual effects team. The VFX studio was double negative, the same team behind Inception. When their lead, Paul Franklin, received Thorne's equations, his first reaction was, "This is going to break our render farm." He wasn't wrong. The simulation took thousands of computers running for months. They generated 800 terabytes of data for a single movie. To put that in context, the entire Lord of the Rings trilogy used about 200 terabytes. But here's what nobody on the production was prepared for. When they finally got the first frame back from the render farm, it didn't look like anything in any astrophysics textbook. The team assumed it was a bug. They started debugging. It wasn't a bug. It was a discovery. When you look at Interstellar's black hole, called Gargantua, the most striking feature is the accretion disk, the bright ring of glowing gas wrapping around it. But it doesn't wrap the way you'd expect. It bends over the top and underneath the black hole simultaneously, forming a halo that looks impossible. That bending is real. It's caused by gravitational lensing, light from the disk behind the black hole getting wrapped around to the front by gravity itself. Thorne's equations predicted it, but no one had ever rendered it visually at this level of fidelity. When the VFX team did, it revealed details about how the disk's brightness distributes that even Thorne hadn't published yet. So Thorne did what scientists do. He wrote 2 papers, one in classical and quantum gravity, one in the American Journal of Physics. The credits include Kip Thorne, Paul Franklin, and the double-negative VFX team. A Hollywood studio became citation material in theoretical physics literature. That had never happened before. You'd think this would be the end of the story. Cool movie, cool papers, the end. Except in April 2019, 5 years after Interstellar's release, an international team of astronomers called the Event Horizon Telescope Collaboration did something that had never been done before. They photographed a real black hole, the supermassive one at the center of Galaxy M87, 53 million light years away. When they released the image, the internet exploded. But film fans noticed something physicists had to admit. It looked uncannily like Gargantua. Side by side, the 2 images share the same essential features: a bright ring of plasma, a dark central shadow, the asymmetric brightness pattern caused by the Doppler effect. The visual structure Hollywood rendered 5 years earlier matched what real telescopes finally captured. This wasn't a coincidence. The equations Thorne wrote in a Hollywood production meeting in 2008 were the same equations the EHT team used to interpret their observations. The simulation got it right because the math got it right. The math got it right because we actually understand how black holes work. We just never visualized them at this fidelity before. In 2022, the EHT released the second ever image of a black hole, Sagittarius A star, at the center of our own galaxy. It also matched Interstellar's predictions. So Hollywood's render is now 2 for 2 against real telescope photographs. As a track record, that's better than most working physicists. But there's a darker side to this story most people don't talk about. The team had to lie. 3 specific scenes in Interstellar deliberately violate the physics. Nolan knew, Thorne approved. The audience never noticed. Here's what they faked, and why. Lie 1. The black hole appears symmetric on screen. In reality, the side rotating toward you would be vastly brighter, possibly tens of times brighter. because of relativistic Doppler shift. Matter on the approaching side slams toward you at near light speed, blue shifting its light, brightening it dramatically. Thorne's physically accurate render showed exactly this asymmetry. Nolan saw it and asked them to make it symmetric. He thought audiences would interpret the asymmetry as a rendering error. Cinema beat science on a marketing call. Lie 2. Miller's Planet, the one with the giant tidal waves, where 1 hour equals 7 Earth years. The time dilation in the script is mathematically possible if the planet orbits incredibly close to the black hole. But at that distance, the planet wouldn't have surface waves. It would have been ripped apart by tidal forces millennia before any humans could land on it. Thorne knew. He let it slide because the dramatic premise was too good to lose. Lie 3. The Tesseract, the 5-dimensional library where the protagonist communicates with his daughter through gravity. Thorne wrote a 35-page appendix in his book on Interstellar's physics, explaining why, even granting every speculative theory we have, this is impossible. There's no known mechanism for love or consciousness to encode information across dimensions. Thorne's argument is that the scene is emotionally true, even when it's physically false. Whether that's a fair compromise is up to you. Which leaves the final, strangest question. If you'd shown the original, scientifically pristine version of Gargantua, the one with the asymmetric Doppler-shifted brightness, would audiences have noticed? Would they have cared? Would they have walked out? Because that version exists. Thorne kept the simulation files. The real physics looks like this. It's stranger, less symmetrical, more alien. One side hot blue, so bright it would burn out a real camera. The other side dim and red, distorted in ways that don't match how the human eye expects light to behave. In the theater, audiences might have read it as a bug, the same way the VFX team initially did. The compromise was probably the right call. Cinema and physics don't always speak the same visual language. A scientifically accurate render that looks broken to viewers is worse than a slightly inaccurate one that lets them feel awe. Nolan and Thorne made the trade. Most physicists agree they made it correctly, but it raises a question this channel will keep coming back to. When cinema and science disagree, who should win? Because they keep collaborating. They keep producing visuals that decades later, real telescopes confirm. And they keep lying, gently, deliberately, to make the universe feel bigger than it is. Next week, how Dune 2 made the sandworms, and what real biology says about why a creature that size couldn't exist on any real planet. The week after, the one VFX trick in Apollo 13 that fooled NASA's own astronauts. If you want to see more breakdowns where Hollywood and science collide, subscribe. Drop the next movie you want decoded in the comments. I read everyone.